Hello, and thank you for joining us for the Black Hills IP webinar, What is Fully Automated US Docketing and Is It for Real? A recording of the webinar and the slides will be made available to all registrants. Feel free to enter any questions using the Q&A feature in the Zoom menu. We invite you to follow us on LinkedIn to see news about other upcoming webinars. And with that, I'll turn things over to our moderator.
Hi, thanks. I'm Tom Marlowe here. And hi, everybody. Thanks for joining us today. Let's take a quick look at the panel that we've got. I'm joined today by a pretty great group of panelists for this webinar. So let me introduce everyone. First, we've got Ann McCracken, who's president at Black Hills IP and a former professor at Franklin Pierce School of Law. We've got Dr. Manjeet Rajay, director of the Center for Applied Artificial Intelligence, professor at the University of St. Thomas, graduate programs in software engineering and data science, and all around AI and computational intelligence expert. There's myself in the middle. Then we've got Zach Lasky-Carrion, docketing manager with the Schweigman firm, and Adam Reese, the IP automation specialist lead with Black Hills IP. So thanks everybody for joining and looking forward to this discussion with you all. So as an overview for this episode, we're going to be looking at docketing automation. Obviously, that's in the title. We'll get a little bit of an overview on automation and artificial intelligence generally, a little bit of that technical framework. We'll go into docketing process and flow and docketing automation, some examples, and then take a look at things kind of as they look into the future here. So the topic of today's webinar, it's docketing automation. And if you're here, you can appreciate the benefits of automation in digital transformation. Docketing automation is a hot topic these days because, well, docketing, it's a very data intensive task with very, I guess you could say, rules driven process, which kind of makes it a very targetable candidate for automation and some of the places to start with respect to digital transformation. A lot of gains can come out of it. But before we dive into docketing per se, let's lay some of the groundwork. And Manjeet, if you don't mind, can you start us off with a little bit of that framework and background?
Sure, absolutely. Thanks a lot, Tom.
Yeah.
So let me begin, talking about AI and automation. The terms, artificial intelligence and automation are often used interchangeably. They're often used together. However, there is a difference between the two. Automation can be achieved by coding up existing rules. Automation systems use and combine data. AI, on the other hand, learns from data and achieves performance which is better or similar than a human. That could be achieving error rates that are better than a human, for example. If you could go on to the next slide, Dan. Automation is not just replicating our old paper-based ways of working with new equivalents like shuffling emails, where we once shuffled paper files. It's about letting the technology do the heavy lifting, easing the workload of humans so that they can focus on quantity and quality rather than the time-consuming task of data entry. Automation isn't just about the way data is entered into the system. It is also about the way it is pulled out of the system, whether in terms of tailored reports or generation of office actions, renewal reminders, or invoicing. Um, AI enabled automation learns the processes, knowledge, and expertise that, you know, maybe in the past only existed in a human's mind in paper files or in sticky note reminders on their desks, and learns from it. Um, the right IP software should provide businesses
That's me.
the right IP software should provide businesses and law firms with a competitive edge by streamlining processes, introducing efficiencies, and deliver an insight necessary to drive decision making. So today, advanced technologies can help in document classification, data extraction, and compliance verification for trademark or patent filing, renewals, and extensions. The key enabling technologies that make this happen today are AI, machine learning, and natural language processing. So I'm going to dive a little bit into these three. Um, AI is often used quite a lot in marketing, in media, but it's not a new shiny thing that has fallen from the sky in the past couple of years. The fact is, it's been around for a very long time, since 1950s. And this picture is showing you, along with the timeline, the birth of AI in 1950s. And then over the years, there have been smaller and smaller subsets of the larger field that have really been able to drive automation in the front. So machine learning is a subfield of the larger umbrella called AI, and then what we these days called deep neural networks or deep learning is even a smaller specialized set of techniques that fall under machine learning. Let me jump back quickly into history here. How did this all start? Um, so the first conference of artificial intelligence was formed in 1956. Dan, if you could go on to the next slide. So this was the first AI conference that ever took place. And back then, there were a number of researchers who were interested in um, developing techniques that can help computers learn from data. And the eventual goal was, can we develop techniques that can mimic humans in certain ways? So these five researchers back then came together and they set out an agenda that um, so basically at the end of this conference, they said, can we come up with certain building blocks that if we are able to automate those, we might be able to achieve generalized human intelligence. So what were those building blocks that they set out to achieve? The first one was reasoning. Let's see if we can teach computers to reason. You're presented with a problem and you reason your way to an answer. Knowledge representation. So represent knowledge about the real world, about our surroundings. To converse and answer questions, computers need to know the surroundings. Next was planning and navigation, for telling us routes, moving. How do I get from point A to point B? If there are multiple paths, choose the best path. Um, Natural language processing. So another thing, even in 1950s, that they were interested in was having computers learn to speak a language, how to create sentences, how to understand the context of sentences. Next was perception. Um, how to perceive things based on vision and sound. And the hope was, if we are able to achieve all of these advances, then probably we will be closer to that generalized human like intelligence. But what in fact happened over all of these years since 1950s is that AI went through a number of boom and bust cycles that we call about that we typically refer to as AI winters. So there were big promises, and then after that there was a lot of disappointment as well. So let me show you the first AI experiment that showed the promise of AI. This was in 1954 during the Cold War. There was a lot of interest in translating English to Russian and Russian back into English. So IBM came up with this experiment. There was a lot of media attention. So what they did was they took 60 um, Russian sentences and translated those into English. And the same thing they did for English sentences, hard coded the meaning and then translated back into uh, Russian. So the example that you see here at the bottom left, what we are showing here is if with the state of technology back then, if you took a sentence in English and you had the system translate that into Russian, and then you took the Russian translated output, fed it back into the system, and had it converted back to the original form, then you would get something like this. So the initial sentence was, the spirit is willing but the flesh is weak. But what you got back after going from English to Russian back into English is, you got, the whiskey is strong but the meat is rotten. So what you can see is that the meaning was not captured. It used to do word for word translation, and if you have enough of these kind of errors, then you would not be able to make any sense out of the body of text. Now that was back then, right, in 1950s. Over the years, there have been many through breakthroughs, with the recent breakthrough in a subfield of um, machine learning called neural networks, which we often refer to them as they having a similar architecture to the neurons that we have in the human brain. Now, neural networks have been around since a similar time, since 1940s and 50s, but they really came out into the forefront with this famous experiment that Google did in 2012. So Google decided to run a large scale experiment. One dimension of scale is data. So they used 10 million YouTube videos, took 200 by 200 still images from those videos, and that was what we call the training set for the machine learning algorithm. The other dimension of scale was computational resources. So they used 1,000 computers, and each computer had 16 cores, it's 16 processors. So, which is a total of 16,000 processors. And they let the algorithms run for a week on those 10 million YouTube videos. If you have a setup like that, you will find what exactly is there in a lot of those videos. And what they found is um, cats, because people love cat videos, and automatically the algorithm was able to detect cats. Um, Now, so out of a total of 20,000 objects, the algorithms were able to recognize 3,200 of those objects automatically. Now, the interesting thing here is that we did not have any human saying, here is how you find cats with nose, with eyes, paws, and ears. Basically, they just fed the neural networks with a bunch of data, and the data learned to categorize the input without any guidance. So, this was a major difference from the earlier techniques that we had seen before. Now, remember, this was in 2012. What I showed you first was in 1950s. And since 1950s up until 2012, AI has gone through a lot of ups and downs, promises followed by disappointments. So the obvious question then to ask is, why is AI working now? What is it that is different now compared to what we had before? So now what is different is you have virtually limitless compute power. Through 50s, 60s, 1970s, 80s, you had to invest in hardware, and that was a limiting factor. Now, with cloud computing, you have access to limitless compute power. Now, that frees up a researcher in developing better algorithms. Earlier, a researcher was always restricted to the limitations of the hardware. So now you have much better advanced algorithms. Third is the support that you have now from the private as well as from the public sector. You have more data available with sensors all over the place. You have IoT data. You had limitations on data in 1950s and 60s as well. So all of these have shown us that more data you have and you make available to a neural network, the performance of the model goes up significantly. So if you look at this picture on the right, the red line is showing you traditional machine learning. And you can see that it used to plateau out. So more data you provide, after a point, the algorithms used to say, fine. Beyond a certain threshold, the algorithms could not really increase the performance. But now, when you have a neural network, so if you have much more computationally intensive large neural network, it is data hungry. You give it more and more data, it is able to achieve more and more performance. And in a lot of experiments these days, you will see that neural networks are able to even beat a human in a number of tasks like recognition, for example. So AI is now embedded in all kinds of software that we use around us. Um, so whether it's a news aggregator like BuzzFeed or Google News, the algorithms behind are powered by deep learning and AI. If you're renting your room out on Airbnb, it comes up with a recommendation that this is the price that you should be probably renting it out for. Pinterest will figure out your preferences and accordingly make recommendations to you. So, as we always say, your recommendation systems have been the most successful applications of AI and ML out there. And picture recognition, um, back when I was in grad school and doing PhD, um, computer vision algorithms always struggled to recognize humans. But now, if you take a picture from your phone, it automatically gets backed up to the cloud and it will perform its own grouping or clustering of pictures. So your pictures followed by your spouse's pictures, they all appear in different clusters without you specifying that this is me and this is my spouse, for example. Next slide, please. So, I showed you the limitations of AI in 1950s. This is where we are today. So on the left, um, it's a picture of Smart Reply, which is a feature of Inbox and Gmail, where the email program suggests three possible responses to received emails. This is the most sophisticated AI model in production today. It's a sequence to sequence model. And what I mean by that is words is they follow a particular sequence. So the AI model has to look at the sequence of words in the email, and then based on that, it comes up with three possible responses, which are again a sequence of words. One is a negative response, one is a neutral response, and one is a positive response. So nobody is sitting and reading those emails. An AI automatically comes up with those responses for you. On the right is an extremely complicated sentence. So if you have a sentence like Paris Hilton, the person was in the city Paris at the hotel Paris Hilton listening to the song Paris. A natural language processing algorithm today can make sense out of that. That is how much far we have come here in terms of the advances that you see. So, hopefully you are convinced that AI is here, AI is powerful, and you need to embrace it to make the most of it and use it to get a competitive advantage. To talk more about the amazing work that they're doing at Black Hills, I will hand it over to the CTO, Tom Marlowe.
Thanks, Manjeet. That's a great technical review, and I think sets the stage well for taking a look at, well, what is the everyday application that we want to be talking about, and today that topic is docketing automation. So as we get started here, we've got a couple of poll questions to get some data from our audience, so we've got a little bit more understanding of who the audience here is. And Michelle, let's see, the first question that we'll have is just understanding what is everybody's role in their organization. Take a couple seconds to answer this, and we'll flash the results here in a second.
And I'll close the poll in about 5 seconds.
Thanks.
Sure.
We've got two more questions here. The next one, oh, here we go. So it looks like we've got a pretty good spread of people, a lot on the docketing and managing and administrating side, and paralegal. Yeah, pretty good spread. Thanks. Next question is, what docketing system does your organization use? Various of these systems may have pieces of automation that they use in various ways. Also, integration capabilities. These things are important to understand what those capabilities are, what you might have at your fingertips, what the limitations might be. And if you use more than one system, just go pick the primary one or the one that's used the most.
And the poll will close in about 5 seconds.
Okay, again, pretty good spread here across systems. Foundation IP being the highest, but only by a little bit, to Memotech, Patricia, CPI. Okay, thanks. And the final question is, maybe to the best of your knowledge, does your docketing system have built-in features for automated docketing? And if so, do you use it? And if you don't know, that's okay.
and we'll give it 5 more seconds.
All right. Thanks everybody for taking the time on these. This is interesting, and this is really cool to see because it sounds like a lot of the majority or the highest amount of responses were that yes, their system does have automated docketing and they do use it. That's great. So docketing automation, like many automation initiatives generally that companies are looking at more and more these days, is simple at the 50,000 foot view. But it has a few moving parts that are necessary to really achieve efficiency gains end to end. If IP docketing, it's a niche area, but has a pretty healthy share of edge cases and maybe what you might call non-obvious details to keep automation experts and configurers pretty busy. Let's take a look on the next slide at some of the pieces that are needed. So with respect to docketing automation, in order to really achieve kind of really good end-to-end automation, there's a few components that are going to be important to have in that process. So first, we need to be able to retrieve, open, and view the documents that are being worked on for docketing. Then in the case of, say, for example, trademark docketing, there might be hyperlinked or there might be additional documents that need to be grabbed to include in a complete docketing activity. So once you've got all the documents, then some work has to be done to identify the matter. So what case is this associated with? And then we need to be able to open the docketing system and get to that matter so that the entry can be updated. And then using the data from the document, identify exactly what it is. And if there are multiple variations of a particular document, identifying what variation we're dealing with in order to figure out exactly how it should be docketed and what should be launched within the docketing system. Let's go to the next. Additionally here, at times more than one thing is needed to be launched within a docketing system. So in the cases where that is the case, having the capability to not only identify but launch one or more items for that case, and entering the data within the docketing system, committing that, meaning confirming that the data is accurate. So whether that be mailing date, publication date, grant date, filing date, priority date, whatever data is being updated into the system is accurate, getting it into the system, and then quality control. So which is something we don't want to overlook, but verifying that what we wanted to go into the system did make it into the system correctly. And then finally, reporting out to the attorney or paralegal that's working on the matter, and reporting out to the client who is the patent owner generally. So at Black Hills IT, where we focus on docking automation, we found these steps are all critical to being able to do full automation end to end. And we haven't seen a lot of other systems that are capable of doing the same end to end work. Certainly retrieving documents from the patent office, getting items launched in some cases within a system. But there's a lot of nuances, and that's part of what we want to cover today to make sure those are well understood. And then on to the next slide. So some of the additional benefits too. When you have data-driven automated processes like this in place, is you can gain these benefits that are generally beyond your standard quality control and efficiency gains. So the first is data integrity checking. So re-scraping data. So this is having the ability to put functions in place to cover or at least identify anomalies. This might include rechecking USPTO data for newly available communications when mailing dates are in the past, and this can happen. So sometimes the sources of the data don't always act exactly and uniformly as one would expect. So having flexible processes to be able to say, okay, this is what we scraped yesterday, this is what we scraped the day before, and now when we look today, there are some new documents that we would have expected to be available yesterday, but we can only now see them today. So being able to deal with those anomalies as they happen is something that can be worked into these types of processes. Expanded quality of verification. So this might include data hooks to be able to grab and compare critical date and deadlines as a backup process. So once you're handling all the data that's coming through for a particular docketing item, being able to re-leverage that data to ensure that the data within the docketing system is up to date. Priority dates are correct. Do we want to recheck critical deadlines every time that we do a docketing event? These types of things can all be done. And then what you might call results-based verification. So being able to close the loop and determine not only did the data get entered as expected, but did the docketing system launch tasks as expected? And this can be configurable based on client requirements or expectations and might be different from system to system. So now on the next slide, let's take a look at the various levels of automation and what they can look like. So the diagram here, it's very similar to the process steps that I went over just a few slides earlier. The details of it, I won't go over again, but it gives you an idea of, in order to have an end-to-end automated process, these are the steps, and kind of this is generally about how the order is going to look. So at the very top, we've got an FA, fully automated type system. You've got a process that can cover all of these steps end to end, from the USPTO to the client report out. And the benefit is you get to sit back and the docket is updated, managed, and reported each day. To try to do this, the fully automation, without having sufficient data or process, you're going to run into problems. We've seen ambitious projects in the past trying to get here without some of the data in the middle. To reference Manjeet's slides earlier, in those cases, typically the whiskey is strong, but the meat is rotten. Now, the next option, if you, in cases where you can't get to a fully automated system, we have the NFA process, which is near fully automated. Here we have a pause, say maybe around about the second or third block, where we're going to inject some sort of manual or expert intervention. This might be confirming a date, adding a piece of data, or something that the machine didn't know or could not find. Once this field is populated, then the rest of the process can continue without further interventions. Sometimes this is needed because you've got a very complicated piece of docketing that has to be processed. Sometimes it's needed because you have a more simply defined automation. You need to take something out for a minute in order to get it back into the process. But you've got a small piece of manual interaction here in the process. The next is your fully automated docketing, or I'm sorry, fully automated data process. So with fully automated data, FAD, this is basically the fully automated process, except that the connection into the docketing system is not there. So if you might be dealing with older docketing systems without an API or data input interface, this is going to be the best that you can get. And here a human is used to populate say pre-prepared data, kind of prepared, massaged, and identified from earlier in the process into the system. And the final type of automation process is your semi-automated structured process. Think of this like a nicely organized assembly line. Compared to if you've got your fully automated system, you've got an assembly line with robotics used all along the way, so something can be put in one end and it gets kicked out the other. With the SASP process, you use people to build the car along that assembly line rather than robotics. So it's an organized, rule-driven process, but you're leveraging humans to perform that repetitive process along the way. Okay, so that gives an overview of different ways to achieve automation within docketing. But maybe what might be helpful here is if we take a look at some practical examples. And do you have some examples we can take a look at? Oh, and if you're talking, I think you might be on mute.
Thanks, Tom.
Yeah,
just to set this up, there's a lot of docketing systems out there that have some level of automation, and they all sound really good in the advertising and marketing materials. And one thing I don't think people think about, though, when they're using these systems is setting them up. So I'd like to go to my first polling question. This is a true or false question. So true or false, docketing systems with built-in automation or auto docketing functions are pre-configured by the docketing system vendor and ready to use, meaning no setup required on the part of the law firm or the legal department.
And we'll give the poll about 5 more seconds.
Okay, so this is consistent with my experience too. In all of the systems that I have seen, the automation or the auto docketing functions are not pre-configured for you. And I think this is a misunderstanding that many people who aren't using their systems yet or using these capabilities yet may have. You really have to make sure that you have resources and available. You have to have a user to set up the rules for these functions in some of these systems that exist out there. And Michelle, we can close the poll results now. So an important thing to understand too is that the rules that you have to configure for these systems to apply any level of automation are pretty primitive. So I just created one. This is a mock-up screen that I created. This isn't out of any docketing system, but it's representative of what we would see in some of these docketing systems that I know our audience uses. So let's say you were going to configure some auto docketing settings in your docketing system. The key limitation that all of the systems have that I've seen are that the rules are limited to PTO document names. So if you're going to create a rule for some type of action to automatically be added into your docketing system, that is going to have to be tied to a particular, very specific PTO document name. Now, let's use the example of a non-final office action, for example. What you typically do in configuring one of these rules is you'd identify the action, you'd identify what or you identify the document, PTO document, you'd identify the action in your system that you want to launch. And I'm just going to say my action is a response due with a 3-month due date. And that's calculated from the US PTO mail date. And that's applied to US and PCT matters. So the reason I say this is very primitive is if you think about what a docketer typically relies on when they're determining what action to add in a docketing system, it's more than just the document name, a lot more than just the document name. The docketer's typically reading at least the summary page on the office action to get more information about that office action. They might be looking at status information in your docketing system. Maybe you docket things differently if an item has a status of transferred, for example, or abandoned, for example. You might look to see if there's previous items that have already been completed in that matter in the docketing system. All of that, plus a number of other things, are what I would call context. A docketer is looking at the context of a document when they are docketing it. The auto docketing rules that are available today in many of these other docketing systems can't look at the context. They just can look at the document name. So I'm going to have another polling question that's going to feel a little out of context, but don't worry, I'll tie this in. So let's go to my next polling question. All right, what is an acceptable error rate for US docketing? Yeah, we can go to the next slide too while they're doing the poll.
And we'll give the poll about 5 more seconds.
Okay. All right, that's kind of what I thought I'd see. Most people said less than 1%. You know, and some of this might depend on the type of organization and the way you use your docket. If your docket is if you're a law firm and this is your primary docket, I would imagine you were in the 68% that said less than 1%. If you're maybe in a legal department that's not using the docket to manage prosecution, you're just using it maybe for internal metrics and status information, you know, maybe a little more. Maybe that's the greater than 5%. But for most people, accuracy is a key thing here. So due to the primitive nature of the functions for automation that are built into these existing docketing systems, there is going to be a greater than 5% error rate when using these auto docketing functions for critical items with due dates like office actions. Now, let me explain why that is. The reason is because of what I just showed you on that previous slide, the limitations of the rules that you build in these docketing systems. We know that not all US office actions are the same. And let's just use non-final to narrow the set of office actions. US non-final office actions. They're not all going to be docketed the same. You have different due dates. Some of them have a 1 month due date, some have a 2 month due date, some have a 3 month due date. Some have other things due that you might docket, like drawings. Some have hidden in them another restriction requirement, as well as the standard office action. Sometimes there's discrepancies that influence how you docket the item. It might say on the second page that it's non-final, but on the last page it says this action is made final. What do you do then? And then sometimes you have different due dates that you would docket based on a special status, like a prioritized or accelerated exam case. So not all office actions are the same. So now put yourself in the position, and Michelle, let's launch the next poll. Put yourself in the position of configuring an auto docketing rule for a US office action in your docketing system where you have to tie the rule to the document name. So your docketing system has multiple actions for US non-final office actions, most do. Which of the following actions are you going to configure to launch for the PTO document named non-final office action? So you only get one of these actions, but you got a whole bunch of actions. I'll give you a minute to think about this, because you got to think about this one a little bit. What are you going to configure your rule to do? Okay, Michelle, let's give them just a few more seconds.
Okay, so I'll close in 5 seconds.
Aha, that's what I thought most people would say too. You guys are so predictable. So when you're faced with this choice, I would go with the action that comes up the most frequently. And in this list of options, that's going to be the non-final office action with a 3-month due date. And that's what 70% of you said. And that's how I would do it too if I was in this situation with limited options. However, even configuring the rule that way, you are going to have a greater than 5% error rate on the way your US non-final office actions are docketed. I looked at the last 6,000 or 7,000 US office actions that we docketed at Black Hills over the last few months. And more than 5% of them were something other than the non-final office action with a 3-month deadline. So if you're, if you're defaulting to that, your automation is docketing that, it's going to be wrong more than 5% of the time. And this audience just told me in my first polling question that that was not an acceptable error rate. So if that's not an acceptable error rate, but you want to take advantage of this functionality, what do? Well, what it means is that you got to check every single one of those items that was auto docketed by your system to see if it actually was a 3-month due date or not, because the system rules can't tell that. And, you know, a lot of the times it will be right, but you still have to spend the human time to go and do that check. And then in more than 5% of those cases, you're actually going to have to remove what was docketed and redocket that action to have it docketed correctly. So, you know, the question was at the beginning of this program, is automated docketing 100% fully automated docketing for real? The answer is yes, it is. But you have to understand what you're looking for and what you're looking at, because there are a lot of systems out there that claim to have 100% fully automated docketing, but they don't. They still require time to configure And more importantly, they still require humans to manage and look over them. And their accuracy actually isn't that great because they're very, very primitive. So that's not fully automated docketing, but it is for real. And what we have at Black Hills is completely different than what these systems that most of you have call automated docketing. We have a middleware solution that works with your docketing system, particularly if your docketing system has an open API. Our technology provides true, fully automated docketing. So let's go to the next slide. So to be 100% automated docketing, a system must support at least these things. It's got to auto docket rules based on context. So for example, it's got to be able to tell that it's looking at an application that's got an accelerated exam track 1 petition request granted and know that that's the case and be able to docket that document differently. I didn't even talk about these other things because we couldn't even get to this level of sophistication with these other docketing systems, but these systems have to be able to add multiple actions for a single document. You know, if you're docketing an office action received and then a supplemental IDS or site art, whatever your action's called, got to be able to add a couple of different actions. You got to be able to de-docket deadlines with automation to be fully automated. You have to be able to auto docket standard foreign correspondence to be fully automated. And you got to be able to verify that the docketing was done correctly to call a system 100% fully automated docketing. And that's what Black Hills offers. I have another slide that we'll just hit on really quick, but I want to not spend much time on it because I want to leave Adam a few minutes to talk about what's involved in setting up fully automated docketing, and then have a few comments from Z. So can we go to my next slide real quick? This is just a set of just kind of a high level summary of some of the reasons that you would want to have true fully automated docketing. The technology is there. It's for real. It's proven. We've had over 3 million items docketed, hands-free, fully automated. It's more reliable and accurate, not only than manual docketing, but even more reliable and accurate than the error rate on the more primitive versions of automated docketing that's out there. Obviously, it reduces a bunch of laborious, tedious tasks. Tom talked about that earlier. And it just simplifies overall the docketing operation, and it's easy to implement. So I'm going to hand this over to Adam to talk very quickly about what's involved in implementing an automated docketing solution.
Thanks, Sam. So at this point, you've seen the benefits of automation, but it may not be clear how to transition to it. Moving toward automation can be a daunting task, especially if you take it in its entirety. But Black Hills IP can make that transition simple with our sophisticated established automation framework that can be tailored to your specific needs. Our process already handles the complexities, and all that remains is to mutually agree on which updates should be made in your system for a given docketing event. That's where this arrow is pointing to. That's the one step we're at in setup. Everything else is built into our automated system. And what this step entails is determining for a set of documents what updates should be made in your docketing system. The updates can be adding or closing an action, updating bibliographic data, or a combination thereof. There may be multiple steps that need to take place in a specific order, and these updates may always occur or only sometimes. Our system has a comprehensive and ever-evolving database of events across countries and file types that allows for as much nuance as necessary when performing these updates. Anne already touched on the non-final rejections, which are a great example of some of that nuance. Another one would be the notice of allowance. What tasks may be added differ depending on the system, the customer, and the contents of the document itself. Are there drawings required? Is there a requirement for biological material? Are there comments from the examiner or reasons for allowance which may require a response? Has the declaration been filed yet? Depending on how you answer these questions, the updates made can vary. And just as docketers look at the documents and make these determinations, our automated system does the same by mapping these scenarios to specific system updates. And your involvement in the details of these mappings of updates can be as much or as little as you like. While we're happy to work with you on customizing these docketing updates to your needs, There's no need for you to spend the time and effort to compile that information. We maintain standardized docketing instructions for major systems, which can quickly be put into use. And even customized systems are not an issue. We can pull reports from your system, and our experts can map your docketing updates to our processes. If you have documentation that can aid in the process, but is not strictly necessary, regardless of what you provide to us, our system will add the correct patent office deadlines. The only difference might be how the update is performed. And if we receive a document which is not yet set up for automation or falls outside of standard scenarios, our system will automatically detect this and switch to a manual processing mode where a docketing expert will personally review and process the item in your system, ensuring that all necessary updates are made. When that initial mapping of document to docketing action is complete, we'll provide you with a list of those events and the corresponding docketing actions. And then you can specify any areas where you'd prefer different docketing actions. And for those customized actions, we'll take any processes that are rooted in manual practice and re-engineer them to align with automated workflows. It's important to note here that if maintaining your existing docketing process exactly is important, then we will need your assistance to ensure what we set up matches with your expectations. If your docketing has particular requirements, but your time is limited at the outset, we can even start auto docketing with only a partial set of events and add more as we go. We commonly find that over 80% of documents downloaded from PAIR are covered by less than 25 events. And another option is starting with just a subset of customer numbers. Whatever your needs, we can work with you to meet them. So if you're interested in automation, please do not hesitate to reach out to us. We can set up automated docketing for you quickly, accurately, and painlessly. And now I'll turn things over to Z, who will speak a bit about the future of docketing.
Thank you. So it is for real, people. I do have to say I have been witness of it and have experienced the benefits of having BHIP handle our docketing. It's legit, too legit to quit, as MC Hammer would say. I read an article that said jobs will be enriched and elevated by AI and machine learning, but the best jobs will be those created to employ AI that links customers to the services and products that they need. And as a Black Hills IP customer, I can say this is what they are doing for us at SLW. Future of the docketing in our professional lives, a lot of people I can see maybe feeling fearful of, oh my God, my job's gonna go away. AI is it has a lot of benefits for for docketing. AI would have a low error rate compared to humans if it's going to be coded properly. And it seems like BHIP it found that way. They are coding our documents that are being scraped from the patent office in the US, EP, WIPO. Just to mention some, and they are finding they are being accurate. There's speed. There's definitely a lot less docketers that are working, docketing our documents into our systems. And it's easy for me as a customer to be able to provide to our clients to be able to report out the documents that have been docketed in our system within a quick turnaround, 3 days, and sometimes within the same day that a document gets docketed into our system. What we see in our professional lives, the future for docketing is we have to define what docketing should be done, the automatically and the ones that will be done by humans. We still need that critical thinking of the humans to get stuff done, but it's not these like laborious tasks that we used to do, like repetitive stuff. Let's leave that to the automation and to people that are dealing with the docketing, so you can turn around and be able to focus on stuff that is not going to be repetitive, that is not tedious tasks, and that would help you focus on stuff that critical thinking is going to be needed. on the professionals working on docketing. I can say that in our department, I have 9 ladies counting myself in the docketing department. And all of this automation, all of the docketing that Black Hills IP does for us, it has helped us focus on other stuff, on opening transferred in matters. So, and for me, I'm going to be very grateful to BHIP for the verification process that they have in place of sometimes contacting me for critical deadlines, like non-recoverable deadlines, like a foreign counterpart deadline. Say, hey, your matter, we noticed that a foreign counterpart deadline was not docketed in your matter. And it wasn't because of docketing. It was because, unfortunately, a matter was open incorrectly. So the verification process that they have in place has really saved our backs and have caught in the initial part crucial deadlines. And therefore, well, the client never even finds out about this. And it's thanks to that first procedure process that BHIP has in place of having their clients back. AI, I can see it's a little overhyped concept. It has more to do with the ability of a machine to handle large volumes of data. And don't worry, all of this doesn't mean that we are replacing human beings' jobs. We still need those people to think out of the box, and we'll make sure that there's stuff that is not being missed, or just in my case, I'm working on transferred in matters, which at this point, human beings need to analyze all of this data that we need to enter into our systems to make sure that the deadlines or due dates are docketed correctly. So right now, AI for us is it's helping for quality of work, for us to have less errors, for more documents to be processed in less time, and more time to be able to focus on other matters or issues that come up. I know 8 years ago or 9, I had heard about this automation as an idea, and I was like, okay, yeah, right. And turning on a side right now and seeing how far we have gone and how much automation has helped my department, myself, and even at Schwegman, it's been amazing. And not because of that, there hasn't been nobody in our firm that has been laid off because of AI. So I totally encourage it. I love working with BHIP, them doing our docketing, because there has been quality of work. And guess what? I don't have to do the docketing. That's something that they have to do for us. Even during the pandemic, I think everybody was a little scared. Oh my God, our jobs are going to be lost. And no, it wasn't the case. AI did not remove anybody. We've actually been super busy. So, anyways, I know we're running out of time, but I did want to say thank you. And if there's any questions, I leave it to Tom.
Thanks, Ian. Thanks for those kind words about working with Black Hills, and a lot of the points that you're making about AI displacing these types of jobs, and seeing in other areas too, very similar, not so much displacing, but more so supporting, which is a great thing. We do have 2 questions that came up. They're pretty quick. I know we're a little bit over time, but we'll cover them. The first one is, do you have this set up for trademarks? Because we've been talking a lot about patents. And the short answer is yes. Some of the fully integrated scraping that we have with the US Patent Office for pulling the documents out is not as complete for trademarks, because the trademark process is more of a push process, where the email notification of docketing comes out of the trademark office, so it's a little bit different, but by and large, the answer is yes. And then this next one, I'm gonna send to Adam. I think it'll be a quick answer, but how is an issue notification automatically docketed? Is the patent number and issue date somehow pulled out of the document and automatically added?
Yeah, so for issue notifications, we do pull the information directly off the document, and it's available to push directly into the system where available.
Perfect. I thought that was going to be an easy one. Okay, well, that's all of the questions that I see. Thanks everybody for joining and sticking with us through this webinar. If you have any questions or want to see or chat about any of this technology further, feel free to reach out. We love talking about it. All right, and to all the panelists, thanks everybody for joining. Manjeet, Z, Ann, and Adam, it's been great. Thanks for all the insights.